So the first thing I always do is look for these two inputs, V plus and V minus, to see if I already know what they are, right? If I have to do any little circuit analysis to get to it. So this one's pretty straightforward. V plus is connected to ground, or to our reference voltage. So we call that 0. And that means this other node is also 0. So in this example, they happen to be 0. All right. So if we know that's 0 volts, then the thing we don't know is V out. And we want to get some information that connects the input side where we know things to the output side where we're trying to solve for it. And that connection is to do KCL at the node that connects the input and output. So even though we know the voltage here is 0 volts, we're going to write KCL at V minus. So I know this node is 4 volts, and I know this node is minus 2 volts, and those are relative to the reference node down here. So we could call this bottom line also put the reference node symbol there. And I'm going to look at all the currents at this node. So I'm going to have, potentially, I'll have current from this minus 2 volt source, from the plus 4 volt source. I have current to the output, and then my current into the OPAmp. I go to the models and say, well, that's 0, so I don't need to include that one. So then I just do my node, a node minus another node over the resistor values to write KCL. So let's say these two are entering, and that's going to equal the one that's leaving. So I would have 4 minus 0 over 4K entering here, and then minus 2 minus 0 over 12K entering from here. It's probably going to go the other way, but that's OK. And then leaving is 0 minus V out over 6K. Those are my 3 currents. The fourth current we know is 0. So let me clean that up just a little bit. 4 over 4K minus 2 over 12K equals minus V out over 6K. All right. So if I multiply through by 12K, I would have 12. Yeah, I could, but 12 minus 4, so make sure I do this right, minus 2 V naught. Oh, duh. Thank you. Minus 2. Is that right? 12, 3, 4, 12, 2, 6. OK, thank you. So 10 equals minus 2 V naught. V naught equals minus 5 volts. Okay. All right, so we have minus 5 volts. That's OK. We don't mind negative voltages. And we would consider this an inverting amplifier because this node that we're analyzing is the inverting node. So we would expect to get an opposite sign out here compared to the input. And then I naught, we could do KCL at V out if we want to know I naught. So I'm going to do that over here so I don't get off the page. KCL at V naught. I would have this one entering now is 0 minus V out, which is minus 5 over 6K. So the same thing I had leaving this other node is now entering this node. And my I naught is drawn entering. So those have to come out to 0. So I'm going to have I naught equals minus 5 over 6K